To start our discussion on unit vectors, I want to begin with this example, which is a common type of problem that you'll see. It says we want to find the component form of a unit vector in the same direction as vector v, and vector v has a horizontal component of -3 and a vertical component of -4. So I'll place that vector in standard position. Here is our vector v. Now, what we want to do is we want to find the unit vector in that same direction. The first thing we know is the word unit. We use it a lot in math. The unit means one. If you're finding a unit rate, you're finding the rate per one. What's the cost per 1 pound or whatever? That would be a unit rate. And so a unit vector, I just want you to know that unit means magnitude of 1. It's a magnitude of 1. So I want to go this direction and write the component form in the same direction as w, but only having a magnitude of 1. So the first thing that we're going to do is let's figure out the magnitude of vector v. And so to find the magnitude of vector v, what we do is we use the Pythagorean theorem. We're going to square the horizontal component and we're going to square the vertical component. And 9 plus 16 is 25. And what we're going to find is that the magnitude of vector v is 5. This is 5 units long. Now what we want to do is we want to write another vector where we're only going to the left so much, we're only going down so much, but we don't want it to have a magnitude of 5, we want it to have a magnitude of 1. And I think to give us a conceptual understanding, let's think about just like a horizontal vector. If I had a horizontal vector here that, let's say the magnitude of this vector w was 10, and I wanted to find the unit vector, you could say, oh, well, the unit vector would be 1 because you just divide the length of this by 10. You could divide its magnitude by 10 because the magnitude 10 divided by 10 is 1. Anything divided by itself is 1. And so if we come back to our example right here, so if I'm looking back at my vector v, which has that horizontal component of -3 and that vertical component of -4, what we can think about, if I went to the left 3 and down 4, we'd have a magnitude of 5. Well, I want to do 1/5 that. So couldn't I do 1/5 of the horizontal movement and 1/5 of the vertical movement? In other words, I could do 1/5 of the horizontal movement and 1/5 of the vertical movement. And this is actually going to be our vector right here. This is our unit vector, -3/5, -4/5. What would it look like on a graph? I mean, it wouldn't look pretty. It would look something like that. It'd be somewhere in there. So our summary is that if vector v has a component form of AB, then the unit vector in that same direction can be given by just taking the horizontal component and dividing it by the magnitude, and then taking the vertical component and dividing it by the magnitude. Why don't you pause and try to do this one on your own? It says, find the component form of the unit vector in the same direction as W. Well, as you know, your first step is going to be to find the magnitude of W. And to do that, I'm just going to use my Pythagorean theorem. And we're going to find that the magnitude of W is 17. Therefore, to find our unit vector in the same direction, I'm just going to divide the horizontal component by the magnitude and the vertical component by the magnitude. This would be the unit vector in the same direction as W. These unit vectors are very helpful because we can use them in conjunction with scalars to create other vectors with linear combinations, as we'll look at in a minute. But what we need to know is our standard unit vectors would be a unit vector that just goes 1 unit to the right, and we use I to refer to that vector, and then a vertical vector that goes up 1 unit, and we're going to call that vector j. This is standard convention. So I typically stay away from using I and j to reference other vectors because I don't want to create confusion. Typically, if you see an I, it means a vector 1 unit to the right, and if you see a j, it means 1 unit up. So right here, I've zoomed way in on a coordinate plane so we can see it. That vector right there, that would be vector I. And then a vertical vector right here, I'm trying to show it in purple. I don't know how well that's going to show up. But that right there is going to be vector j. Those are our standard unit vectors. And so as I mentioned, a linear combination of unit vectors is a sum of vectors and scalars. And so an example would be 3u minus 2v. And so what we'll see a lot of the time is we'll rewrite a vector as a linear combination of unit vectors. So instead of using u and v, we'll use the I and the j we used on the previous slide. And here's an example of that. It says given vector v with an initial point here and a terminal point here, we want to write vector v as a linear combination of the standard unit vectors. Now, I've copied the vectors down here for us to reference. But first, what we need to do is we need to find the component form of vector v. And so to find the component form of vector v, we need to figure out its horizontal movement. It looks like the horizontally, it goes from 1 to -3. So its horizontal movement is -4. That's its horizontal component. And it looks like vertically, it goes from -2 to 6. So its vertical component is 8. And so all we do to write it as a linear combination of standard unit vectors is you think, what do I need to do horizontally to get from 1 to -4? And hopefully you're saying, oh, well, to get to 1 to -4, we just do -4 times I. And then how do we get from a positive 1 to an 8? Well, that's just going to be 8j. This is rewriting this vector as a linear combination of the standard unit vectors. It's not a complicated process mathematically, but it's a tool that you'll need quite a bit. If you were to take I and copy in the component form there, and you were to take j and copy in the component form there, and you were to multiply each of those vectors times their scalars, and then add them together, you'd end up back where we started. So just, you can go through that exercise if you want to prove to yourself that this is equivalent to this. But that's really all you need to know on unit vectors. You need to know basically those few skills. You need to be able to rewrite a vector in the same direction as a unit vector, as we did on our first couple of slides. You need to know what your standard unit vectors are, and you need to be able to rewrite any vector as a linear combination of the standard unit vectors. If you can do those things, you're good to go.